Hello and welcome to the second video on bivariate data. Today we are going to talk about correlation and linearity. In the last video, we introduced scatter plot, which gives an intuitive visual indication of possible relationship between two variables. However, it is difficult to assign a specific strength of a linear association using the graphical display. Therefore, there is the correlation, which is a mathematical measure of the strength of a linearity. In this video, we will talk about the correlation coefficient, the corresponding linearity, and the coefficient of determination. But before we get started, I just want to remind everyone that no matter how strong the linear correlation is, it is not an indication of causation. The correlation coefficient, sometimes simply called the correlation, is designated by R. It is defined in terms of the means and the standard deviations of the two variables x and y. The formula is R equals the sum of the products of the corresponding z-scores of the two variables divided by 1 less than the sample size. Then, the n here is the number of data. The xi and yi are the data values of the x and y variables, respectively. And the x bar and y bar are the respective means. The sx and sy are the standard deviations. Inputting the information into a calculator, we can use this formula to determine the correlation coefficient very quickly. However, it is important to understand that this formula suggests that the correlation does not distinguish between the independent and dependent variables. That is, it doesn't matter which variable is assigned as x and which is assigned as y. The correlation coefficient is always the same. Also, since the formula is based on the z-scores, which do not have units, unit changes do not affect the correlation. Lastly, since we use the means and standard deviations, which are prone to be influenced by outliers, to calculate the z-score, the impact of extreme values are huge on the z-scores, and therefore are huge on the correlation coefficient. From the definition of R, it is always true that the absolute value of R is no larger than 1. The closer the absolute value is to 1, the stronger the linearity. The smaller the absolute value, the weaker the linear association. If the absolute value of R is 1, it suggests a perfect linear relationship, meaning that we can use a best fit line to connect all the data. However, because the correlation only reflects on the linear association, an R of 0 means that there is no linear relationship, but it does not mean that there is no relationship at all. There could be a strong nonlinear relationship between the two variables instead. When talking about correlation, we consider not only the absolute value of R, but also its sign. When R is negative, it indicates a negative association, and a positive R value stands for a positive correlation. Looking at this graph, R is positive 1, so the best fit line passes through all points and has a positive slope. Over here, the best fit line also passes through all points, but its slope is negative, so R is negative 1. Down on these two graphs, the data are not exactly on the best fit lines, but they scatter around them, so the R values are close to 1. The signs of the R values also indicate whether the relationships are increasing or decreasing. When R is 0, there is no evidence for a linear relationship. Finally, the coefficient of determination is simply R squared. It gives the percentage of variation in the observed Y values that can be explained by the X variables using a best fit line. Since the absolute value of R is no larger than 1, people like to give the coefficient of determination in terms of a percentage. If the absolute value of R is 1, the coefficient would be 100%, meaning that we can predict all Y values accurately using the X variable in the equation for the best fit line. The coefficient of determination is widely applied in experiments and observational studies, and the desirable values are different depending on the context. Time to recap what we learned today. We started with the definition and characteristics of the correlation coefficient. Then, we made connections between the R values and their corresponding linearity. Lastly, we talked about the coefficient of determination, which has many applications in experiments and observational studies. I hope you enjoyed this video and see you soon.